Okay, so here we are preparing for your exam over limits, right? So we're just going to be talking about limits, the definition of limits and how we do limits, one-sided limits, infinite limits, all things limit. Okay, so first we're starting off with some questions about the limit basics. Okay, so we have our graph of f and we have our graph of g. Notice there's an open circle here, but then the point is actually up here. Okay, we have a couple of open circles over here on G also. So our first questions are asking us about the basics of our f function. The limit as x approaches -2 of our f function. Okay, so we come over here and we examine where x is -2. Okay, so this is the point that we're looking for. And as we talk about limits, we're looking for the y value that the graphs are going towards from both the left side and from the right side. Okay, and it looks like this y value is going to be +4. So the limit as x approaches -2 is +4, right? That's the y value when x equals -2. The graphs are going towards the y value of 4. Okay, number 2 says f of 1. So that means what is the y value when x is 1? So here's when x is 1, and notice there's an open circle, but the point is way up here. Okay, the y value is the point, not where the graph is going necessarily. So the y value is going to be 4 again for this one. The y value, the dot, the point on our graph when x is 1 has a y value of 4. Okay, as opposed to part C, which asks for what is the limit. Remember, the limit, we're talking about the graph. So where is the graph approaching as you go towards +1 along the graph from the left and the right? Well, the graph is approaching +1. Okay, the graphs are going towards +1, but the actual y value is way up there at +4. Okay, and then our last question about f says, what is the y value when x is 2? So we come down, and the y value when x is 2 looks like it's -2. Okay, so the difference between a y value from your graph and the limits on the graph, okay, are two important distinguishable concepts. Okay, now look at g of -2. Remember, g of -2 is going to be the point of our graph at -2. So this point has a y value of +1. Okay, the same thing for f, g of +1. So over here at 1, notice we have a closed circle at -1. Okay, so the y value is where the closed circle is, or the dots. Now, if there was not a dot on there at all, if it was just an open circle on both sides, then the y value would be undefined. Okay, if there's not a closed dot anywhere on the graph for that x value, then it's undefined. Okay, what's the limit as x approaches -2? So where is our graph going? Right, so a limit is talking about the graphical. The graph is going towards -1. Right, the y value there of the graph looks like it's going to go towards -1. And what about the limit as x approaches +1? Well, from the left side, our graph is going towards -4, and from the right side, our graph is going towards -1. And since -4 and -1 are not the same number, the limit at +1 does not exist. Okay, so the limit does not exist if the left side and the right side go to different values. Okay, and then g of 3, what's the y value when x is 3? Well, that's just this point here on the graph. It looks like the y value is +3. So the difference between a y value from the graph and a limit from the graph. Okay, it's an important distinction that I need you to know how to differentiate between those two concepts. The point of your function versus the limit of the graph. Okay, so down here it says, it wants you to arrange the limits from least to greatest. So which of these three has the smallest answer? That's what it's asking for. Okay, so it has some properties of limits. So we're talking about the limit as x approaches -1. Right, that's what we're looking for. So for f, the limit as x approaches -1 is what y value? -1. The y value is up here at 3. So this is 3. 3 plus 4 is 7. And then from g, as g approaches -1, the y value is 0. 0 minus 1. Okay, 0 minus 1 is -1. So 7 divided by -1 is -7. Okay, so another property, here we have 3 times the limit of g of x, once again, as x approaches -1. So the g function was 0, and the f function was 3, correct? So this is 0 minus 21, which is -21. And our last one, -5 times, I believe this was 3 again, times g of x, which is 0. So this limit is going to be 0. So which of these is the smallest? Well, the 3 g of x minus 7 f of x, right? That limit is smallest. And then our next one would be f of x plus 4 over g of x minus 1. And then the largest of these functions would be minus 5f times g, right? Being lazy and not, oh no, I'll write of x. So the limit in order, right? So we're trying to arrange these limits from least to greatest. So we do all of the calculations for each of these problems, and then you arrange their numbers from the most left, the most negative, to the most positive. Okay, arranging them in order. Okay, now the rest of these look, oh, actually number 2 is a nice algebra problem, maybe. So anytime we're trying to evaluate a limit, our first option is to use direct substitution. Just plug x into all of the parts, okay, and see if you get a number, because if you get a number, then that's your answer, right? But if you get zeros over zeros, then we have to do some sort of algebraic manipulation. Okay, so 2 times 36, because 6 squared is 36, minus 54 minus 18. 2 times 36 is 72. This is also 72, so our top is 0, and the bottom, 6 minus 6 is 0. Okay, right, so this isn't actually part of the problem. This is just allowing us to know that now we have to do some type of algebraic manipulation. Okay, so anytime we have a polynomial, the manipulation we want to do is factoring, right? We want to factor this polynomial. So on top, 2x squared minus 9x minus 18 has got to factor to 2x and x, right? Those are our coefficients of our two factors, because the first two things of your FOIL give us 2x squared. So one of them has to be 2x, and the other one has to be x. And then our last numbers have to multiply to give us negative 18. So whatever I put here and there, those two numbers must multiply to give us negative 18. Okay, and there's lots of options. So here's the problem with this, is that there's options. There can be 1 and 18, or 2 and 9, or 3 and 6, where one of them is positive and the other one is negative. Okay, so my brain is seeing right now that if I do 2 times negative 6, that's negative 12. And if I add 3 to negative 12, does that give me negative 9? It does. When I do my O, I get negative 12x. And when I do my I of FOIL, I get positive 3x. Negative 12x plus 3x is negative 9x. Okay, so I know I have the correct factors if, when I multiply these things out all the way, if I FOIL them, some say, I get my starting quadratic. So because when I FOIL, I get these three numbers, I know that I have the correct factors. Okay, so I have an x minus 6 on top, but what do I have on bottom? 6 minus x. It'd be really nice if I could cancel x minus 6 with the 6 minus x, but those are not, in fact, the same thing. So I'm going to do a little trick. I'm going to rearrange my furniture here. Right? This is negative x plus 6. These are the same things. 6 minus x and negative x plus 6 are the same. So what if I just pulled out a negative from each of these terms? That means this is now a positive x, and what's the opposite of plus? Is a minus. Okay, so this is one of our tricks that we can use, and this is really the only trick that we do use, so that we have things that directly cancel out or divide out. Okay, because now I have an x minus 6 in the numerator and an x minus 6 in the denominator, right? Not something that looks close to it. I can't cancel 6 minus x with x minus 6 because those aren't the same. So now that I've done that, I'm taking the limit as x approaches 6 of my 2x plus 3 over negative 1, right? When everything cancels out, I still have a 1, and I have my negative sign. Okay, so I have my negative sign in the denominator, but now I can plug in 6, right? So I do this algebraic manipulation so that I no longer have a 0 over 0 when I use direct substitution. So this is 12 plus 3 divided by negative 1, which is a total answer of negative 15. So the graph is trying to approach negative 15 from the right side and the left side of my original function. That's what this means. Okay, so this next part, what do you remember about the natural log? Let's see. So direct substitution, what happens when we plug a natural log in here? What is the natural log of 1? You need to know that the natural log of 1 is 0, right? Because anything raised to the 0 power equals 1. And the answer to a log is always the exponent. The answer to a log is always an exponent. Okay? So we have, what about the limit as x approaches 0 from the right of our natural log function? Okay, so if you remember anything about natural logs, which I don't think you do, but that's okay. You're still a fantastic person. Lots of people don't know anything about logs, and they're perfectly happy. Logs have a vertical asymptote through 0. Right? We can't take the natural log or the log of a negative number. And we said that the log of 1 is 0, so that's at this point. And then our logs are always increasing, so it graphs something like this. So what is happening to our graph on the right side of 0? It's going down to negative infinity. Okay? The graph is going down towards negative infinity, right? The natural log of 0.1 is like, I don't even know what it is, but it's a negative number, right? So our y values are getting more and more and more towards negative infinity, which means that the limits to the right, does not exist. But we're just going to write negative infinity. But if negative infinity is a multiple choice and it's not on there, then the limit from the right does not exist because it goes down and down and down forever. Okay, what else do we know? Let's plug in E, right? Direct substitution is our main thing for limits. What is the natural log of E? Well, if you remember from your log properties, natural log is log base E. And anytime our bases are the same, the answer is 1. So the natural log of E is 1, which means on our graph, if I go E units to the right, then I go 1 unit up. Okay? E is 2.71828, right? That's the approximate number for E. This is a number like pi, 2.71828. It's one of those existential numbers. So the natural log of E is 1. just like the natural log of 1 is 0. Okay, it's one of those properties of logs. Okay, so the limit as x approaches 1 of e to the x. So direct substitution. E to the 1 is e, right? 2.71828. So as x approaches 1 of e. So let's look at the graph of e to the x. Shall we do that? Remember, this is an exponential graph, so it crosses at positive 1. And as you go to the left, we get closer to 0. And as you go to the right, it grows exponentially. So as x approaches 1, our y value is going towards e, 2.71828. So how about this next one? What's the limit as x approaches 0? All right, so you plug in 0, e to the 0. Anything to the 0 is 1. Okay, so there's a little section here about limits and natural logs and the number e. So don't be surprised if you see an e problem on your test coming up. Okay, number 4, when we plug in 8, right? I don't know if you know this, but 8 cubed is apparently 512. So 8 cubed minus 512 is 0. And 8 minus 8 is 0. So we're going to use our factorization, right, your special factorization for the difference of cubes. So if we have, x cubed, if we have a cubed minus b cubed, right, that factors to a minus b, right, the cube roots of each of those terms, times a squared plus ab plus b squared. Okay, that is a special cubic factorization that you either need to memorize or use the table on the wall for. So this has an a value of x and a b value of 8. Okay, so we're taking the limit as x approaches 8 of x minus 8. Right? This is your a and this is your b. So then our next thing is x squared, right? Plus 8x, because a is x and b is 8, but we always put the number in front of the letter, so 8x, plus 8 squared, which is 64. All divided by, okay, we have 8 minus x, so what does our trick say to do? Take the negative of x minus 8, right? So this is our trick. This is our trick factorization. We want to have an x minus 8 so it can divide and cancel with the x minus 8 on top. But it is not x minus 8, it's 8 minus x. So we use our trick and make it the negative of. So negative of 8 minus x is negative x minus 8. Okay, so wonderful. Now those things cancel out and we're no longer going to have any minuses. Okay, so now when we use direct substitution, we plug 8 in everywhere. 64 plus 64 plus 64 divided by negative 1 is our answer. Okay, so here's twice where we've had this factor trick. Okay, so just so that you're aware of this factor trick. If you ever have something that's similar but opposite, then you have to make it the negative in order to factor it correctly.